Hello students, welcome back to the maths class. In previous class, we have derived the equation of a line passing through a point and parallel to a given vector. So let us recall what are its vector form and Cartesian form, and next let us proceed with the new derivation, that is equation of a line passing through two given points. In previous class, we have studied when we have derived the equation for a line, equation of the line passing through a point and parallel to given vector, parallel to one vector, that is we are deriving the equation of line in three-dimensional geometry. So we have a point. This point A is on the line L, and this line L is parallel to a vector. Means we have derived the equation of this line, which is passing through a point A and parallel to the vector B. In order to derive, we considered another point P on the line L, and the position vector of the point P is R, and the position vector for the point A is vector A. Here we derive the vector form as vector R is equal to vector A plus lambda times vector B, and Cartesian form as x minus x1 by A, which is equal to y minus y1 by B, which is equal to z minus z1 by C. Okay? So this was the derivation which we have derived, and here in today's class we are going to derive the equation of a line which is passing through two given points. You should always remember in yesterday's class it was equation of a line passing through one point, that is a given point, and parallel to a vector. In today's class we are going to derive the equation of a line passing through two given points. Let us learn this, try to understand. So here you can see you have a line. This line is passing through two given points, that is point A and point B. And the position vector of the point A is vector A, and the position vector of the point B is vector B with respect to the origin O. In order to find the equation of this line, I am considering another point, say P. The position vector of the point P is vector R. And the Cartesian coordinate of the point A is x1, y1, z1, and B is x2, y2, z2, and P is x, y, z. Okay, so we are going to derive the equation of this line which is passing through the 2 points A and B. So let us first write what are the things, what are the data we know here. So here, let vector A and vector B be the position vector of the point A and B respectively on the line. Let R be the position vector of the point P. Okay, we have considered the point P on this line under one condition, that is the point P is on the line if and only if AP, that is the vector AP and vector AB are collinear. Only under that condition we have taken this point, that is then point P is on the line if and only if, okay, point P is on the line if and only if vector AP and vector AB are collinear. Okay, that is vector AP, so the direction is in this direction. Vector AP and vector AB are collinear vectors. Under that condition, we have considered the point P on this line. So we already know if the two vectors are collinear. For example, if vector A and vector B are collinear, what can we say? We can say that vector A is lambda times vector B, or we can even say that vector B is lambda times vector A. So let us write this condition. So here we know that vector AP and vector AB are collinear vectors. So I can write vector AP is equal to lambda times vector A. Okay, now how to write vector AP? We know that vector AP can be written as vector OP minus vector A. That is the terminal point minus the initial point of the vector, which is equal to lambda times vector AB. Vector AB can be written as vector OB minus vector OA. Okay, so here what is vector OP? Vector OP is given by vector R, then vector OA is given by vector A, which is equal to lambda times vector B minus vector A. Therefore, vector R is equal to vector A plus lambda times vector B minus vector A. So, this is the vector form of the equation of the line which is passing through two given points. Now let us derive for Cartesian form. So for Cartesian form, since we know the Cartesian coordinate of the point A, B and P, we can write its component form of the vector. So here vector R is given by vector R, which is for the vector OP, can be written as xi cap plus yj cap plus zk cap, and vector A, the Cartesian coordinate of the point A is given by x1, y1, z1. So vector A can be written as x1 I cap plus y1 j cap plus z1 k cap, and vector B, which is equal to x2 I cap plus y2 j cap plus z2 k cap. So let us derive the Cartesian form of the equation. So here we know that vector R is xi cap plus yj cap plus zk cap, and vector A is x1 I cap plus y1 j cap plus z1 k cap, and vector B is x2 I cap plus y2 j cap plus z2 k cap. This we can write because we already know the coordinates of point A, B and P. Once we know the coordinates, we can easily write its component form of the vector. So we already derived the vector form of the equation of the line which is passing through two given points. We derived that vector R is equal to vector A plus lambda times vector B minus vector A. So this can also be written as vector R minus vector A is equal to lambda times vector B minus vector A. So I am going to substitute these values in equation number 1. So substituting these values in equation number 1. So we have vector R minus vector A. So vector R is xi cap plus yj cap plus zk cap minus vector A, which is x1 I cap plus y1 j cap plus z1 k cap. This is our RHS, which is equal to lambda times vector B minus vector A. So vector B is x2 I cap plus y2 j cap plus z2 k cap minus vector A, which is x1 I cap plus y1 j cap plus z1 k cap. So subtracting the two vectors, so when I subtract xi cap plus yj cap plus zk cap minus x1 I cap plus y1 j cap plus z1 k cap, we get x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap, which is equal to lambda times. Again here also we are going to subtract the two vectors. So we get it as x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Okay, in the right hand side, let us multiply the lambda inside. So we have in the left hand side x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap, which is equal to lambda times x2 minus x1 I cap plus lambda times y2 minus y1 j cap plus lambda times z2 minus z1 k cap. Now, equating the coefficients of I cap, j cap and k cap. So, equating coefficients of I cap, j cap and k cap, we get. So, what is the coefficient of I cap in the left hand side? It is x minus x1. That in the right hand side, it is lambda times x2 minus x1. So, x minus x1, which is equal to lambda times x2 minus x1. Similarly, next, equating the coefficient of j cap, we get y minus y1, which is equal to lambda times y2 minus y1. And of k cap, it is z minus z1, which is equal to lambda times z2 minus z1. So, this can be written as x minus x1 by x2 minus x1, which is equal to lambda, y minus y1 by y2 minus y1, which is also equal to lambda, z minus z1 by z2 minus z1, which is equal to lambda. Therefore, the Cartesian form of the equation of the line is given by x minus x1 by x2 minus x1, which is equal to y minus y1 by y2 minus y1, which is equal to z minus z1 by z2 minus z1. Understood? So, this is the Cartesian form of the equation of the line. Cartesian form of the equation of the line passing through two given points. Let us solve the problem on the equation of a line passing through two given points. So here in the first problem, they have asked us to find the vector equation of a line passing through the points minus 1, 0, 2 and 3, 4, 6. Okay, so the first point what they have given, we should consider the first point for vector A. So the Cartesian coordinate is given, you can write it in vector components. So this can be written as minus 1 I cap plus 0 j cap plus 2 k cap. And the second point, that is for vector B, so this will be written as 3 I cap plus 4 j cap plus 6 k cap. We need to find its vector equation. So vector form of the equation of the line is given by vector R is equal to vector A plus lambda times vector B minus vector A. Now let us start substituting the values of vector A and vector B in the vector form. So vector R is equal to vector A. So vector A is minus 1 I cap plus 0 j cap plus 2 k cap. Then plus lambda times vector B minus vector A. So vector B is 3 I cap plus 4 j cap plus 6 k cap minus vector A, which is minus 1 I cap plus 0 j cap plus 2 k cap. Okay, now you should simplify this. You should subtract these two vectors. So this is equal to minus 1 I cap plus 0 j cap plus 2 k cap plus lambda times. Now we have 3 minus of minus 1. 3 minus of minus 1, it is 4. So 4 I cap, then 4 minus of plus 0. So 4 minus 0, it is 4 plus 4 j cap. Next 6 minus of plus 2. 6 minus 2. 6 minus 2 is 4. So plus 4 k cap. So this is the vector form of the equation of the line. Next problem, we need to find the vector and Cartesian equation of the line that passes through the origin and 5 minus 2 and 5 minus 2, 3. Okay, here the first point they have given it as origin. So what are the Cartesian coordinate of origin? It is 0, 0 and 0. So vector A, the first vector is 0 I cap plus 0 j cap plus 0 k cap. And second vector, vector B is given by 5 I cap minus 2 j cap plus 3 k cap. So the vector form of the equation of the line is given by vector R is equal to vector A plus lambda times vector B minus vector A. Now substitute these values in the vector equation. So vector R is equal to 0 I cap plus 0 j cap plus 0 k cap, which is equal, plus lambda times vector b minus vector a, which is 5I cap minus 2j cap plus 3k cap minus 0I cap plus 0j cap plus 0k cap. That is your vector A. So this is equal to 0I cap plus 0j cap plus 0k cap plus lambda times. So 5 minus 0, it is 5, x minus 2 minus 0, it is minus 2, then plus 3 minus 0, it is 3 again. So 5I cap minus 2j cap plus 3k cap. This is the vector form of the equation of the line for the given 2 points. Next, let us find its Cartesian form. Cartesian form is given by x minus x1 by x2 minus x1, which is equal to y minus y1 by y2 minus y1, which is equal to z minus z1 by z2 minus z1. So here, when I have written vector A and vector B, what is its general form? It is given by x1I cap. Vector A is given by x1I cap plus y1j cap plus z1k cap, and vector B is given by x2I cap plus y2j cap plus z2k cap. So now compare and tell me what is the value of x1, y1, z1 and x2, y2, z2. Once we know the values, we can directly substitute in the Cartesian form. So here x1 is 0, y1 is 0 and z1 is also 0, and x2 is 5, y2 is minus 2, z2 is 3. Now let us start substituting. X minus x1 is 0 divided by x2 value is 5 minus x1 is 0, which is equal to y minus y1, again it is 0, y2 value is minus 2, y1 is 0. Therefore, this is equal to z minus z1 value is 0 divided by z2 is 3, again z1 is 0. So x minus 0 it is x, 5 minus 0 it is 5, y divided by minus 2, which is equal to z divided by 3. So this is your vector form and the Cartesian form for the points, that is 0, 0, 0 and 5 minus 2, 3. Next problem, here also we need to find the vector and Cartesian equation of the line. So they are given 2 points. So the first one, it is for vector A. So it is given by 3I cap minus 2j cap minus 5k cap. And the second is vector B, which is given by 3I cap minus 2j cap plus 6k cap. We know that vector equation is vector R is equal to vector A plus lambda times vector B minus vector A. So vector A, which is 3I cap minus 2j cap minus 5k cap plus lambda into vector B, which is 3I cap minus 2j cap plus 6k cap minus vector A, which is 3I cap minus 2j cap minus 5k cap. Therefore, this is equal to 3I cap minus 2j cap minus 5k cap plus lambda into, so here 3 minus 3, so it is 0I cap. Next we have minus 2j cap minus of minus 2j cap. So it will be minus 2j cap plus 2j cap. So it is 0j cap. Next we have 6k cap minus of minus 5k cap. So 6k cap plus 5k cap, it is 11k cap. So this is the vector equation of the line. Next, Cartesian form, which is given by x minus x1 by x2 minus x1, which is equal to y minus y1 by y2 minus y1, which is equal to z minus z1 by z2 minus z1. So here, vector A is nothing but x1I cap plus y1j cap plus z1k cap, and vector B is x2I cap plus y2j cap plus z2k cap. Now compare and write the values of x1, y1, z1 and x2, y2, z2. So x minus x1, which is equal to 3 divided by x2, it is 3 again, minus x1 is 3. So this is equal to y minus, the value of y1 is minus 2, y minus y1 value is minus 2. So y minus of minus 2 divided by y2. y2 is given by again minus 2 minus y1 is minus 2. And so this is equal to z minus z1. z minus z1 value is minus 5 divided by z2 minus z1. z2 is 6 minus z1 is minus 5. So this is x minus 3 by 0. 3 minus 3, 0, which is equal to y minus into minus plus 2 divided by minus 2, minus of minus plus, minus 2 plus 2, 0, which is equal to z plus 5 divided by 6 minus of minus 5. So 6 plus 5, which is equal to 11.